Welcome to Summarize Science, where we look at the latest breakthroughs in technology. Have you ever wondered how computers can turn a few flat photos into a full 3D world? A group of researchers from Tsinghua University has introduced a new model called IVGT, which stands for Implicit Visual Geometry Transformer. It is designed to solve a fundamental problem in computer vision, recreating 3D shapes from regular, unposed images. In the past, most 3D scanning methods worked by creating point maps, which are basically giant clouds of dots. While these dots show the general shape of an object, they often have gaps, look messy, and require lots of extra processing to look smooth. The authors of this paper argue that these older methods are often redundant and lack geometric continuity. IVGT takes a different approach by learning a continuous neural scene representation. Instead of just placing dots, this model creates a mathematical field that can be queried at any point in 3D space. It uses a transformer backbone, which is the same kind of technology that powers modern language AIs, to look at all input photos simultaneously. By doing this, the system can understand the relationship between different viewpoints without being told where the camera was located. This allows it to build a unified map of the scene in its internal memory. The difference between the old way and this new way is like the difference between a connect-the-dots drawing and a smooth sculpture. As seen in the diagrams, the explicit model produces discrete points, while the implicit model generates a continuous surface. This means the final result can be viewed from any angle, even angles that weren't in the original photos. It can even predict the colors and surface normals for every single point it recreates. The framework works by taking those unposed RGB images and running them through an encoder to extract features. These features are then aggregated to create a neural representation of the entire scene. When the user wants to see a specific part of the object, the model performs a continuous 3D query to find out what is there. This results in high-quality outputs like depth maps and 3D meshes. Look at these examples where the model reconstructed various indoor rooms from just a few snapshots. The surfaces are geometrically complete and look very similar to the ground truth versions. Even with objects of varying scales, like teddy bears or pumpkins, the AI produces visually consistent results. Because it is generalizable, it can work on new scenes it has never seen before in a single forward pass. When compared directly to previous methods, the improvements are very clear. Old point map representations often look sparse and have broken edges, especially around the boundaries of objects. The IVGT mesh, however, shows significantly improved geometric continuity and completeness. This demonstrates that modeling geometry as a continuous field is much more effective than using discrete points. The system isn't just for building models, it can also render entirely new views of a scene. These rendered images look sharp and realistic because the AI understands the underlying 3D structure. It can even figure out exactly where a camera was pointing when a photo was taken, a task called camera pose estimation. To wrap up the key points, IVGT creates smooth, high-quality 3D models from simple photos without needing camera data. It outperforms older methods by treating geometry as a continuous mathematical field rather than a cloud of dots. In the future, this technology could make it incredibly easy for anyone to create 3D assets for games or virtual reality using just their phone. It could also help robots navigate and understand their surroundings more accurately and quickly. Thank you for watching Summarize Science, and stay tuned for more amazing tech breakdowns.